This is section 1.2, part B, comparing distributions. Some of the most interesting statistics questions involve comparing two or more groups. Which of two popular diets leads to greater long-term weight loss? Who texts more, males or females? Do the number of people living in households differ among countries? Of the following example, suggest you should always discuss the shape, the center, and the spread, and any possible outliers when you're comparing distributions of quantitative variables. So this is an example of how many people live in households in the United Kingdom and South Africa. To help answer the question, we used census at schools and randomly selected 50 students from each country. The dot plot of the household size reported by the survey is given. So we need to compare the distribution of household size for the two countries. When you're comparing these, you always need to look at the shape, the center, and the spread. So if we look at the shape for South Africa, we can see that we have a peak here, it goes down, and then it stretches out to the right. So this data set would be skewed to the right, and it is unimodal because there's only one peak. For the UK, we go up, we have a peak, and then it comes right back down. So that is unimodal, and it is more roughly symmetric. Next, you would need to look at the center. So remember, when you're looking at the center, you're looking for the middle number. In this case, to find the middle number, it's very easy to see that the middle number for the UK is going to be less than 5, where the middle number for South Africa is definitely going to be more than 5. So the center for South Africa is higher than the center for the UK. The spread for South Africa, we're going all the way from 26 down to about 3. So 26 minus 3 gives us 23. Where the spread for the UK, you're going from 6 people down to 2 people, which only has a spread of 4. We're going from 6 to 2, that would be a spread of 4. So the range for South Africa of 23 people is much larger than the spread for the UK, which is only 4. When we discuss outliers, it doesn't appear that there's any outliers for the UK. All data points are between 2 and 4. But for South Africa, this value out at 26 definitely could be an outlier. Notice that we discussed the distribution of household sizes only for 2 samples of 50 students in the previous example. We might be interested in whether the sample distribution gives us convincing evidence of a difference in the population distribution of household sizes in South Africa and the United Kingdom. Now remember, we're only looking at a sample population. We are looking at a sample size. So the sample data is only telling us about these 50 individuals we looked at. If we look at a population distribution, this will look at the population of all people that live in those countries. So we will have to wait a few chapters to decide whether we can reach such a conclusion. But our ability to make such an inference later will be helped by the fact that the students in our sample were chosen at random. So a tip when you go to take your AP exam, when comparing distributions of quantitative data, it's not enough just to list values of the center and spread for each distribution. You have to explicitly compare those values. So say which one is greater than, which one is less than, or say if they're about the same. Another simple graphical display for fairly small data sets is a stem plot, also known as a stem and leaf plot. Stem plots give us a quick picture of the shape and distribution while including the actual numerical values of a graph. So if we have the numbers 12, 13, 14, 15, 17, 20, 21, 23, 25, 32, and 34. When you go to make a stem plot, you are going to have a vertical line. On the left side of the vertical line, you are going to put the tens position. So in this case, we have a 1, a 2, and a 3. And on the right side, you put the ones position. So for 12, we have a 1 and we would have a 2. For 13, we have 1 and 3. 14 is 1 and 4. 15 is 1 with a 5. 17 is 1 and 7. 20, 21, 23, 25, and then 32 and 34. When you make a stem plot, it's also important to make a key so that we know that 2/1 represents 21. So someone understands how to read your stem plot. So again, the steps to do this, you're going to separate each observation into a stem consisting of the final digit and the original digit, or the tens or the 100s, however you're splitting these up, and the leaf, which is the final digit. We're going to write the stems in a vertical column with the smallest at the top, the largest at the bottom. Draw a vertical line to the right of this column. Do not skip any stems. So if we would have had a 50 in there, we would also have to add a 4 and then a 5 in the tens positions. Write each leaf in the row to the right of its stem. Arrange the leaves in increasing order, and then make sure you provide a key. So how many pairs of shoes does a typical teenager have? To find out, a group of AP Statistics students conducted a survey. They selected a random sample of 20 female students. The following is the number of pairs of shoes that each respondent reported having. Here are the data. So if you notice, we have values in the 10, 20, 30. The largest we have is 50. So if we needed to create a stem plot, we would need to go from 10 all the way up to 50. Now, in the tens, we have 3 13s and a 15. So we have 3 13s and a 15. In the 20s, we also have a 19. In the 20s, we have 22, 23, 23, a 24, 26, and 26. In the 30s, we have 30, 31, 34, and 38. In the 40s, we only have 49. And in the 50s, we have 50, 51, and 57. We have two 50s, sorry. It is important to try to line them up. I messed up on that last one. So to try to line them up so all the first numbers are in a column together, all the second numbers are in a column together, all the third numbers are in a column together, so it's easier to look at the shape. So here is another example of that. Make sure that you provide a key. So in this case, we have 4/9 represents a female student who is reported having 49 pairs of shoes. And it is important that you put this context back into it, that we're talking about a female student and the shoes, so anyone that looks at this graph can easily understand what we are discussing. Sometimes a stem plot does not give you very much information on the data set. It is possible to get a better picture by splitting stems. So if we want to not just have one line for all tens, anything from 10 to 20, we could split it up. Now it is important to have each stem have the same number of possible values. So it's really usually popular to break them down either by every 2, so 10 and 11, then 12 and 13, 14 and 15 would go together, or to break it up every 5. So 10 to 15, and then 10 to 14, and then 15 to 20. You can go about that route. If the stems are split into fives, each stem is listed 5 times. If it's split into 2 sections, it would each be listed 2 times. So if we take a sample of 20 male students who also took a survey of how many pairs of shoes that they had, if we look at the original data set, this does not give us a whole lot of information. But if we split the stems, and so we'll do 0 through 4, and then 5 through 9, the next one would be 10 through 14, and then 15 to 19 on the next one. We would do 20 to 24, 25 to 29, 30 to 34, and 35 to 39. Now by splitting this, it's easier to see that we have a group here and then it trails out to the right. So it's much easier to identify the shape of the data in splitting stems. With the split stem plot, we can see that the data is definitely skewed to the right. It's also possible to have 2 sets of data that share the same stem. This is called a back-to-back stem plot. One set of data would be on the left and one would be on the right. So if we look at the same data we just looked at for females and males, we can split the stem plot and we can also make it back to back, and then we can compare the data. So it's much easier to see that the females have a center that is much higher than the males, and it's easier to have comparisons. So when you are making stem plots do not work well with large data sets where each stem must hold a large number of leaves. There is no magic number of stems to use, but 5 is a good minimum. Too few or too many stems will make it difficult to see the distribution shape. If you split stems, be sure that each stem is assigned an equal number of possible leaf data. So 2 stems each have 5 possible leaves, 5 stems each have 2 possible leaves. You can get more flexibility by rounding the data so that the final digit after rounding is suitable as a leaf. So use the previously made back-to-back stem plot to write a few sentences comparing the number of pairs of shoes owned by males and females. Be sure to address the shape, the center, spread, and outliers. So it appears that the females have more pairs of shoes than males in general. The median reported for the males was 9 pairs of shoes, while the female median was larger at 26 pairs. Females also have a larger range. They range from 57 to 13, which is a range of 44, in comparison of a range for the males, which goes from 38 to 4, which is only 34. So the range of the females of 44 is larger than the range of the males. Both males and female distributions are skewed to the right. It is skewed towards the larger numbers, though the distribution for the males is more heavily skewed, as evidenced by the possible outliers for the males of 22, 35, and 38. The females, however, do not appear to have any outliers. So this question is going to be multiple choice. Here is a stem plot of the percent of residents aged 65 and older in 50 states and the District of Columbia. So this means we do have 51 data points. The stem are whole percents and the leaves are tenths percents. So 8/8 would be 8.8%. The lower outlier is Alaska. What percent of Alaskan residents are 65 or older? So since we know this stem represents a decimal place, this would be 6.8%. Ignoring the outlier, so if we ignore that 68, the shape of the distribution is, if we look, we have one peak, it goes down to the right, it goes down to the left. So that one would be roughly symmetric. And the center of the distribution is close to. One way to look at the center is to look at the median. Now, since we know there are 51 data points, the 26th data point should be in the middle. So if you count until you get to the 26th data point, you should end up at 12.8%.